What if the ground beneath your feet could whisper stories from 1,000 years ago? Not in words, but in shades, deep browns, rusty reds, pale grays, each layer a page in an ancient diary written by time itself. This isn't science fiction. It's the real magic of archaeology, where soil isn't just dirt. It's a time machine. Every settlement, every civilization that ever rose and fell, left behind a secret code in the earth, and today we're cracking it wide open. Picture this: you're standing in a quiet field, nothing but grass and wind for miles, but beneath your boots, the soil holds the echoes of markets bustling with traders, homes filled with laughter, and moments of unimaginable change. The colors of the earth, those subtle shifts in hue, are like fingerprints, each one revealing a chapter of human history. A dark, ashy layer might whisper of a catastrophic fire. A sudden streak of vibrant red could hint at ancient rituals or the remnants of a long-lost feast. These are the clues archaeologists follow, like detectives piecing together a puzzle where the pieces are made of time itself. This journey isn't just about science, it's about connection. It's about realizing that the past isn't some distant, untouchable thing. It's right here, woven into the very ground we walk on. And with every scoop of soil, we're not just uncovering artifacts, we're meeting the people who came before us, hearing their stories in a language of color and sediment. So let's dig in literally as we explore how these hidden hues reveal everything from forgotten battles to everyday moments, and how the earth itself became the ultimate historian. By the end of this, you'll never look at a patch of dirt the same way again. The science behind decoding these earthy time capsules is called stratigraphy, a word that might sound technical, but really, it's just the art of reading dirt like a book. Think of each layer of soil as a paragraph in history, stacked one on top of another over centuries. The darkest layers, rich with decomposed plants and charcoal, often tell tales of human activity. These are the moments when people settled down, built homes, tilled the land, and left behind traces of their daily lives. A thick, blackened streak might reveal an ancient hearth, while a crumbly, nutrient-packed layer could mark where crops once flourished. But then there are the lighter patches, pale, sandy stretches that feel almost barren compared to the layers around them. These are the silences in the story, the gaps where life seemed to pause. They might signal periods of drought when fields turned to dust, or moments when entire communities packed up and moved on, leaving the wind to scatter their footprints. And sometimes there are abrupt, jarring shifts, a layer of ash from a volcanic eruption, or a sudden deposit of silt from a catastrophic flood. These are the exclamation points in the soil's narrative, moments when history took a sharp, unforgettable turn. What's truly remarkable is how these layers don't just sit there passively, they interact. Roots from later plants snake through older layers, burrowing animals mix up the timeline, and rainwater carries minerals downward, staining the earth in new ways. Archaeologists have to untangle all of this, like detectives separating overlapping voices in a crowded room. By cross-referencing soil colors with artifacts, a pottery shard here, a tool fragment there, they can pinpoint exactly when a village thrived, when it struggled, and when it vanished. It's not just about digging up the past, it's about listening to the quiet, colorful conversation between humans and the land they called home. The colors in soil aren't just random, they're like nature's paintbrush, carefully blending shades over centuries based on what's happening above and below the surface. Take iron, for example. When it reacts with oxygen over time, it creates those striking rusty reds and oranges you might spot in certain layers. These hues often signal periods when the ground was exposed to air, maybe because farmers were tilling the land or a settlement was expanding. But where you find deep, chocolatey browns or near black streaks, that's usually the work of organic matter, leaves, roots, even food waste slowly breaking down and enriching the earth. These darker layers are like snapshots of daily life, showing where people cultivated crops, cooked meals, or simply lived in harmony with the land. Then there are the grays and pale yellows, subtle but telling. Silt deposited by ancient floods can leave behind these lighter, almost dusty layers, marking moments when rivers burst their banks or storms reshaped the landscape. And if you ever come across a thin, ashy line running through the soil like a shadow, you might be standing atop the remnants of a long-ago fire, whether it was a controlled burn to clear fields or the tragic aftermath of conflict. Even something as simple as a patch of unusually white soil could reveal where lime was spread to balance acidity, a trick farmers have used for thousands of years. But here's what's fascinating: these colors don't just appear overnight. They're the result of slow, relentless teamwork between climate, plants, and human hands. In wetter regions, constant rainfall leaches minerals downward, creating distinct bands of color. In drier areas, evaporation can pull salts to the surface, leaving behind ghostly white crusts. And every time someone planted a crop, built a house, or even walked the same path for generations, they left behind tiny chemical changes that shifted the soil's palette. It's a canvas that never stops evolving, where every shade is a clue waiting to be read. Now let's step into one of history's most fascinating time capsules, the ancient city of Çatalhöyük in Turkey. Buried beneath the earth for nearly 9,000 years, this sprawling Neolithic settlement is like a masterclass in soil storytelling. The layers here aren't just dirt. They're a living diary of one of humanity's first great experiments in community living. Take the darkest, richest layers first. These deep, almost black streaks are packed with organic material, decayed food scraps, charcoal from ancient hearths, even the remnants of reed mats that once lined homes. Every shade here whispers of continuous life, generation after generation living atop the same foundations, literally building their future on the past. The sheer density of these layers tells us Çatalhöyük wasn't just a village. It was a thriving hub where families cooked, crafted, and celebrated for centuries without interruption. But then the story takes a turn. In certain spots, the soil shifts abruptly to lighter, sandier tones like a record skipping mid-song. These pale layers are starkly different from the fertile darkness around them, and they hint at something unsettling. Maybe a prolonged drought parched the land, forcing people to ration food or relocate temporarily. Or perhaps a shift in trade routes left the community isolated, their once bustling streets growing quieter over time. These transitions aren't just geological, they're emotional, marking moments when resilience was tested. And then there are the fire chapters. Thin, ashy bands slice through the soil like scars, telling of blazes that tore through tightly packed mud brick homes. Unlike modern cities where fires might be controlled, a single spark in Çatalhöyük could leap from roof to roof. Homes were so densely clustered, people walked across them like streets. Some burns seem accidental, traces of a cooking fire gone wrong. Others are more ominous, with patterns suggesting entire sections were abandoned after the disaster. Yet what's most extraordinary isn't the destruction, it's the rebirth. After every fire or drought, the people returned. New layers of dark soil appear atop the ash, proof that life here wasn't fragile, it was stubborn. They rebuilt, replanted, and remembered. Even their rituals left marks. Bright red ochre stains in the soil reveal where bodies were buried beneath homes, painted for the afterlife. Every color, every layer is a decision, a struggle, a triumph. Çatalhöyük soil doesn't just show us how these people lived, it shows us how they endured. While the colors in soil might seem like the work of time and weather alone, there's a hidden workforce shaping these huge microorganisms. These tiny architects, invisible to the naked eye, are master chemists, transforming organic matter and minerals into the rich palette we see in archaeological layers. Every dark, crumbly streak of soil packed with nutrients, that's the handiwork of bacteria and fungi, breaking down leaves, wood, and even animal remains over centuries, leaving behind humus, a dark, carbon-rich material that's like nature's ink, staining the earth with stories of life and decay. But the real magic happens in waterlogged environments where oxygen is scarce. Here, anaerobic bacteria take over, slowing decomposition to a crawl. Without oxygen, organic matter doesn't fully break down, creating thick, black layers of peat or muck. These are nature's time capsules, preserving everything from pollen grains to ancient seeds in astonishing detail. In places like Ireland's bogs or the wetlands of the Amazon, these microbial processes have saved delicate artifacts, wooden tools, textiles, even human remains that would have vanished in drier soils. The darker the layer, the more we can thank these microscopic preservers for holding onto fragments of the past that might otherwise have been lost. Yet microorganisms don't just preserve, they also betray human activity. When archaeologists find patches of unusually dark soil in otherwise lighter layers, it's often a sign of ancient farming or waste disposal. The bacteria thriving in these areas leave behind telltale chemical signatures, like elevated levels of phosphorus from decomposed food scraps or manure. Even the faintest grayish streaks can hint at long-gone compost pits or the ash from burned crops. By studying these microbial fingerprints, scientists can separate natural soil changes from the marks left by human hands, revealing where people planted, fertilized, or even ritually buried offerings centuries ago. What's astonishing is how dynamic this process is. A single teaspoon of soil contains billions of microorganisms, each playing a role in the grand color-changing symphony. Some bacteria oxidize iron, turning the earth rusty red. Others produce sulfides, creating bluish-gray patches in waterlogged sites. And when conditions shift, say, when a flood recedes or a forest is cleared, the microbial community adapts, altering the soil's chemistry and hue within years or even months. This means the colors beneath our feet aren't just a static record. They're a living, breathing ledger, constantly updated by unseen scribes. So the next time you see a patch of dark, fertile earth, remember, it's not just dirt. It's a masterpiece painted by microbes. Farming doesn't just feed civilizations, it etches its history into the soil itself, layer by layer, season by season. Those dark, crumbly bands rich with organic matter, they're like love letters from the past, proof of careful tending, where generations of farmers enriched the earth with compost, manure, and crop rotations. These fertile streaks tell us where ancient hands worked the land with patience, coaxing bounty from the ground. But flip the page, and you'll find lighter, thinner layers, pale, almost exhausted soils where the earth was pushed too hard. These are the cautionary tales where overplanting or deforestation stripped the land of nutrients, leaving behind a ghostly residue of what once was. Take the terraced hills of the Andes, where Inca farmers transformed steep slopes into lush gardens centuries ago. The soil there tells a story of ingenuity, dark, loamy layers threaded with gravel for drainage, a perfect balance of human innovation and respect for the land. Contrast that with the Dust Bowl of the 1930s, where American plains turned to swirling clouds of pale, lifeless dirt. The soil didn't just fade, it screamed of plows tearing too deep, of monocultures sucking the earth dry. These aren't just historical footnotes, they're urgent reminders that the ground remembers every choice we make. But here's the twist: sometimes the soil hides surprises. In the Amazon, researchers stumbled upon patches of mysteriously dark earth called Terra Preta fertile islands in a sea of otherwise poor soil. These weren't natural, they were crafted by indigenous people who mixed charcoal, pottery shards, and compost into the earth, creating supercharged soil that still thrives centuries later. It's a testament to forgotten wisdom, a blueprint for how farming could work with nature instead of against it. And nestled in these layers are clues to crops we've lost, seeds of ancient grains, traces of forgotten fruits, waiting to teach us how our ancestors fed themselves without chemicals or machines. The real lesson: soil isn't just a backdrop for history, it's an active participant. When Roman vineyards flourished, their terraces left behind distinct reddish layers laced with grape pollen. When medieval farmers abandoned fields during the Black Death, the earth slowly healed, growing darker and richer under a blanket of wild grasses. Every layer is a negotiation between human ambition and the limits of the land. Today, as we face climate change and soil degradation, these ancient patterns offer more than just stories. They're a survival guide written in dirt, if we're willing to read it. The ground remembers catastrophe with startling clarity. When earthquakes ripple through the earth, they don't just topple buildings, they scramble soil layers like a deck of cards shuffled mid-game. Archaeologists call these jumbled bands seismic horizons, chaotic zigzags where once orderly strata were twisted by unimaginable force. In Turkey's ancient city of Troy, researchers found one such layer, a jagged mess of broken pottery and tilted soil that perfectly matches historical records of a massive quake in the 13th century. The earth didn't just record the event, it preserved the violence of the moment frozen in dirt. Then there are floods, nature's archivists in liquid form. When rivers overflow, they dump thick, sudden layers of sand or silt atop everything in their path. These deposits are like timestamps, clean, uniform sheets that stand out against darker, organic, rich soil. In Mesopotamia, the cradle of civilization, flood layers tell a story of both destruction and renewal. One particularly thick band of silt near corresponds with a legendary deluge described in the Epic of Gilgamesh, suggesting these stories weren't just myths, but communal memories etched into the land. The soil remembers what oral histories merely whisper, but nothing stamps time quite like volcanic ash. When a volcano explodes, it blankets entire continents in a signature layer of fine, glassy particles, each eruption chemically unique. Take the Terra eruption around 1600 BC, which buried the Minoan city of Akrotiri under meters of pumice. That same ash turned up in Egypt's Nile Delta, Turkey's coast, and even Greenland's ice cores, creating a global sync point for archaeologists. One gray stripe in the soil can link an Egyptian pharaoh's reign to a Greek fishing village's downfall, proving how interconnected ancient worlds really were. What's astonishing is how these disaster layers don't just mark endings, they reveal resilience. Beneath Pompeii's infamous volcanic ash, there's older, darker soil showing vineyards that flourished after an earlier eruption. In the American Midwest, silt deposits from ancient Mississippi floods are topped by thin, deliberate layers of charcoal, proof that indigenous farmers burned debris to restart fertility. The soil doesn't just chronicle ruin, it documents the stubborn human instinct to rebuild season after season, catastrophe after catastrophe. These bands of color and texture are more than geological records, they're the longest-running dialogue between humanity and the unpredictable planet we call home. One civilization's trash is an archaeologist's time capsule. Those dark, lumpy layers packed with broken pottery, animal bones, and charcoal aren't just ancient garbage. They're meticulously kept diaries of everyday life. Take the Viking middens of York, England, where compacted refuse heaps revealed everything from fish scales to worn-out shoes, painting a vivid picture of 9th century meals, fashions, and even seasonal feasts. The richer and darker the layer, the more it hums with human activity, charcoal from countless cooking fires, bones cracked open for marrow, and shattered dishes that once held hearty stews. These aren't accidental deposits, they're communal archives, carefully placed beyond living spaces yet close enough to hint at daily rhythms. But then there are the gaps, those eerily light, almost sterile layers sandwiched between the chaos. In the abandoned cliff dwellings of Mesa Verde, sterile bands of windblown silt separate periods of intense puebloan activity, marking years when drought or conflict drove people away. The absence speaks volumes. No charcoal, no food scraps, just nature reclaiming empty spaces. Yet even these silent stretches hold clues. Tiny root traces or insect burrows can reveal how long the land lay fallow before someone returned to rebuild. And sometimes the most telling marks aren't objects at all. In the loamy soils of Neolithic Scotland, faint discolorations outline long-vanished wooden posts, ghostly rectangles where homes once stood. The soil remembers what wood has long forgotten. Similarly, in Roman Britain, subtle tool grooves in the subsoil betray the precise spots where surveyors marked out roads, their chisels leaving behind mineral stains that outlasted stone pavements. These invisible fingerprints prove that human hands don't just leave behind things, they leave behind spaces, patterns, intentions. What's extraordinary is how these layers interact. A midden might start as a simple refuse pile, but as generations toss in shells, bones, and broken tools, the weight compresses everything into a nutrient-rich dark mass. Plants take root, drawing minerals from the decay, and their roots weave through the debris, creating a living tapestry of past and present. Even the humblest garbage layer becomes a collaboration between people and nature, a record of sustenance, survival, and the unbroken chain of needing, using, and discarding that connects us to every civilization before us. Some of history's most fertile secrets are hidden in plain sight, patches of soil so dark and rich they seem to defy nature. Scattered across Europe, these enigmatic stretches of black earth or Terra Preta don't just stand out visually, they pulse with life, bursting with nutrients even after centuries. Unlike the surrounding pale, tired earth, these pockets are nearly black, crumbly with organic matter, and often littered with pottery shards like a breadcrumb trail left by a forgotten civilization. The mystery: this isn't natural. Someone made this soil on purpose. The clues point to an ancient recipe lost to time. Modern tests reveal these dark layers are packed with biochar charcoal crushed into fine particles and mixed into the earth like a tonic. But it wasn't just charcoal. Ancient farmers blended broken ceramics, food waste, even fish bones into the ground, creating a self-renewing sponge that held moisture and nutrients far better than untreated soil. In Germany's Rhineland, these patches align with vanished medieval villages, their dark earth still yielding bumper crops today. In the Amazon, Terra Preta covers swaths of land larger than entire countries, proving indigenous people transformed poor rainforest soil into agricultural gold centuries before modern agronomy existed. What's revolutionary isn't just the technique, it's the philosophy. These cultures didn't extract from the land, they collaborated with it. While modern farming often depletes soil in decades, these ancient patches remain fertile after 1,000 years. Scientists now think the charcoal acts like a coral reef for microbes, creating a bustling underground ecosystem that regenerates itself. even more astonishing. These methods are being rediscovered today. Farmers from the Netherlands to Brazil are experimenting with carbon farming, blending biochar into degraded fields, watching as lifeless dirt slowly darkens and revives, proof that the ancients might have held the key to sustainable agriculture all along. Yet the full story of these dark earth patches remains tantalizingly out of reach. Why did some cultures adopt this practice while others didn't? Were these fertile islands accidental byproducts of settlement or deliberate acts of ecological engineering? In Romania, black earth sites overlap with Bronze Age trade routes, suggesting knowledge might have spread like a precious commodity. Meanwhile, in England, similar soils appear near Roman villas, hinting at forgotten agricultural wisdom passed down through conquest. Every dark streak in the earth is a question wrapped in a riddle. How many other sustainable secrets did our ancestors bury, waiting for us to dig them up? The same soil that holds the echoes of ancient civilizations also carries a meticulous record of the planet's moods, shifts in climate, etched into the earth like pages in a weather diary. Take pollen grains, for instance. These tiny, nearly indestructible capsules preserved in the damp embrace of peat bogs are time travelers. A single handful of bog soil might contain pollen from grasses that swayed during a warm medieval summer, or from hardy shrubs that clung to life during an ice age. By counting and identifying these grains layer by layer, scientists can reconstruct entire landscapes that vanished millennia ago. In Ireland's bogs, a sudden shift from tree pollen to grass pollen tells of forests cleared by early farmers. In Greenland, the absence of pollen altogether marks the brutal grip of advancing glaciers. These are more than just botanical snapshots. They're climate reports written in the quiet language of plants. But pollen isn't the only witness. Hidden within the crystalline structure of soil minerals are oxygen isotopes, variants of oxygen atoms that act as nature's thermometers. When rainwater seeps into the ground, it carries a chemical signature shaped by the temperature at which it evaporated. Warmer periods leave behind higher ratios of oxygen-18, a heavier isotope, while colder eras favor lighter oxygen-16. By analyzing these ratios in ancient soil layers, researchers can trace temperature fluctuations with astonishing precision. In the American Southwest, soil isotopes revealed a decades-long megadrought that likely contributed to the ancestral Puebloans' sudden departure from Mesa Verde. In the Sahara, they expose a startling truth. What's now the world's largest desert was once a lush grassland, its soils rich with the isotopes of a wetter, greener past. What's chilling is how often these climate shifts align with pivotal moments in human history. The thin, dusty layers in Egyptian Nile sediments coincide with records of famine during the Old Kingdom, when the river's life-giving floods failed. In Mesopotamia, soil salts crusting over fertile fields tell of irrigation systems gone wrong, salinization from overwatering during prolonged droughts, a cautionary tale of agricultural overreach. Even the legendary collapse of the Maya civilization finds its footing in soil archives. Sediment cores from lakebeds show layers of drought so severe they're punctuated by bands of ancient wildfire ash. Yet for every collapse, there's a story of adaptation. In the Andes, Incan farmers built step terraces that trapped moisture during dry spells and drained excess water during floods. Their engineering prowess written into the soil's alternating layers of gravel and organic matter. In Southeast Asia, rice farmers developed intricate water management systems that left behind distinct, waterlogged soil strata, proving resilience isn't just about surviving change, but learning to dance with it. These archives don't just warn us of past vulnerabilities, they offer blueprints for ingenuity. The sobering lesson: climate change isn't a modern phenomenon, It's the backdrop against which every human struggle and triumph has played out. But today, as we face our own planetary shifts, these soil-stored memories remind us of something vital. Civilizations don't fail because the climate changes. They fail when they stop listening to the land. The Earth has been keeping score for millennia, and if we know how to read it, the soil might just hold the wisdom we need to write a different ending. War leaves scars not just on people, but on the land itself, hidden beneath the surface in ways only soil can reveal. Take the rolling fields of Gettysburg, where nearly 160 years after the Civil War's bloodiest battle, the Earth still whispers secrets. Here, metal detectors aren't just tools for hobbyists. They're time machines revealing concentrated pockets of lead bullets that missed their mark and sank into the dirt, waiting to tell us where soldiers stood, how lines shifted, and where the fighting grew fiercest. But the real story isn't just in the metal. It's in the soil's chemistry. Elevated phosphorus levels trace where fallen soldiers were hastily buried, their bodies enriching the earth in ways that linger for centuries. Even the plants behave differently here. Certain grasses grow taller and greener over mass graves, their roots feeding on nutrients released by decomposition, a living map of loss. Then there are the fires of war, seared into the earth like brands. In the layers beneath medieval castles, archaeologists find thin, ashy stripes, evidence of siege engines hurling flaming projectiles, or defenders burning their own stores to keep them from enemy hands. But sometimes the burns tell quieter, more personal stories. In the Scottish Highlands, patches of charcoal-rich soil mark the spots where clans torched their own homes rather than let them fall to invaders, a practice known as scorched earth. The soil remembers the desperation in those flames, the choice between destruction and surrender. But perhaps the most haunting traces are the ones unseen. In the killing fields of World War I's Western Front, the earth is still riddled with iron pan, a dense, rust-colored layer formed by millions of shell fragments oxidizing underground. This isn't just metal, it's the soil itself transformed by war, its very structure altered by years of bombardment. Farmers in Flanders still plow up shrapnel today, their blades clicking against the past. And in the forests of Verdun, the ground is so pocked with craters that rainwater pools in unnatural patterns, creating ghostly reflections of explosions that tore through the earth over a century ago. Yet even in these grim archives, there are glimpses of humanity. In ancient Maiden Castle, England, a mass grave from a Roman assault shows something unexpected. The skeletons are carefully arranged, some with offerings of food or coins. The soil here is darker, richer, not just from decomposition but from the respect paid to the dead. Conflict shapes the land, but so does compassion. Every layer, every discoloration is a dialogue between violence and memory, written in the only language the earth knows how to speak. Beneath the quiet surface of sacred sites lies a hidden language of fire and reverence, layers of soil transformed by generations of rituals, each one leaving behind a chemical whisper of devotion. Take the ancient temple mounds of Cahokia in North America, where archaeologists uncovered a striking pattern: thin, alternating bands of ash and dark earth, stacked like pages in a spiritual ledger. These weren't random burns, they were deliberate, cyclical acts, perhaps seasonal offerings or purification ceremonies, repeated so often that the ground itself became a testament to faith. The ash layers, brittle and light, tell of fires kept meticulously small, not for warmth or cooking, but for something far more intangible. Mixed in are flecks of charred herbs, seeds, and even fragments of rare minerals like mica, glittering like forgotten prayers pressed into the earth. Then there are the burials, those intimate disturbances in the soil that speak louder than any epitaph. In the Neolithic tombs of Europe's Orkney Islands, researchers noticed something peculiar. the earth around certain skeletons was stained a deep reddish-brown, a hue distinct from the surrounding layers. This wasn't natural oxidation. It was the residue of decomposed organic materials, woven baskets, leather shrouds, or wooden biers that once cradled the dead. Even more telling were the grave cuts, the precise edges where ancient hands dug into older soil layers, leaving behind a sharp color contrast. These subtle disruptions reveal not just how people buried their loved ones, but how they marked the sacred from the mundane. A burial pit's fill might mix lighter topsoil with darker subsoil, a deliberate blending of layers that symbolized the union of life and death. But sacred soil isn't always solemn. At Mexico's Çatalhöyük, the Pyramid of the Feathered Serpent hides a playful secret beneath its imposing steps, thick deposits of mercury-rich soil, a surreal, silvery layer that shimmers under scrutiny. This wasn't pollution, it was alchemy. The metal, painstakingly extracted from cinnabar ore, was used to paint ritual objects and corpses, creating an otherworldly glow for ceremonies. Nearby, pockets of soil packed with shattered pottery and animal bones suggest feasts where vessels were smashed intentionally, their fragments buried as offerings. The ground here isn't just a repository, it's a mosaic of celebration and sacrifice, where every color and texture was orchestrated for the divine. What's extraordinary is how these sacred signatures persist. In India's Varanasi, one of the world's oldest continuously inhabited cities, the ghats along the Ganges reveal a stratified tapestry of devotion. Layers of marigold petals, coconut husks, and ceremonial ashes have compressed over centuries into a fragrant, ochre-streaked soil unique to this holy site. Even the act of walking millions of barefoot pilgrims treading the same path has polished the earth into a smooth, almost glassy surface, a physical manifestation of collective reverence. The soil here doesn't just record rituals, it becomes one. Yet these sacred layers do more than document practices, they rewrite history. In Turkey's Göbekli Tepe, a site so ancient it predates agriculture, the soil exposed a shocking reversal of conventional wisdom. The deepest layers weren't domestic refuse but ritual debris. Charred bones of aurochs and gazelles piled in deliberate circles proved that hunter-gatherers built monumental temples before settling into villages. The very order of human progress was hidden in the dirt. Similarly, in Peru's Caral Soup, sterile white sand layers beneath pyramids revealed a startling truth. The first stones were laid not on bedrock, but atop purified earth, meticulously cleansed of any organic material. This wasn't construction, it was consecration. The lesson, sacred soil is more than a backdrop for human drama. It's an active participant. Every ashy streak, every stained patch, every oddly textured layer is a collaboration between earth and spirit. And as archaeologists brush away the centuries, they're not just uncovering lost rituals, they're touching the moments when soil itself became holy. The ground doesn't just remember local history, it holds receipts from across the world, stamped with the chemistry of distant lands. When ancient traders unloaded their exotic wares in bustling marketplaces, they left behind more than just artifacts. They left chemical signatures that seeped into the very soil. Take the vivid purple stains found in Mediterranean ports, traces of Tyrian purple dye extracted from rare sea snails. This wasn't just a color, it was a status symbol so valuable, its production was guarded like state secrets. Wherever this royal hue appears in soil layers, it whispers of elite trade networks stretching from Phoenician workshops to Roman villas. But luxury goods weren't the only imports leaving traces. In Viking Age York, the soil tells a quieter story of everyday connections. Elevated levels of zinc and copper in certain layers align with the arrival of German ore, evidence of a metals trade that fueled local blacksmiths. Even something as humble as a banana peel could rewrite history. In a London excavation, archaeologists found soil enriched with tropical fruit residues, proof that medieval merchants were bringing treats from Africa or Asia centuries earlier than written records suggested. These aren't just stray clues, they're fragments of globalization's first draft written in elements and isotopes. Coastal sites add another layer to the story. In Peru's desert valleys, miles from the ocean, soil packed with anchovy bones and seashells reveals how the Moche people turned fish into a currency of empire. They dried their catch into portable protein, trading it inland for cotton and precious stones. The soil here isn't just dirt, it's a ledger of supply chains, with each silvery fish scale representing a journey across ecosystems. Similarly, in Bronze Age Turkey, layers of murex shells far inland mark the routes of purple dye caravans, their discarded containers slowly crumbling into the earth like expired passports. What's astonishing is how these chemical breadcrumbs can overturn assumptions. For years, historians believed the Silk Road was primarily an overland route until soil tests in Siberian settlements revealed traces of Indian black pepper and Chinese tea. These spices couldn't have survived the arid desert crossings, suggesting a forgotten northern network of rivers and trails. Elsewhere, in West Africa, the unexpected presence of Mediterranean olive pollen in ancient urban soils hints at trans-Saharan trade routes active long before camels dominated the dunes. The earth remembers what ledgers decayed, what maps burned, yet the most poignant trade signatures aren't always grand. In a humble Anglo-Saxon village, soil analysis uncovered a single layer rich in sunflower seeds, a plant native to the Americas, impossible in pre-Columbian Europe. At first, it seemed like a dating error. Then researchers realized these weren't ancient seeds at all. They were modern contaminants dropped by archaeologists snacking during digs. A reminder that even our own footsteps are now part of the soil's ever-growing archive, adding new layers to an ancient conversation between Earth and explorer. Digging through a modern city's soil is like trying to read a book that's been rewritten 100 times, each generation scribbling over the last, leaving behind a jumble of mixed-up pages. Urban archaeologists face a unique challenge. How do you untangle 2,000 years of constant rebuilding, where ancient streets lie buried under parking garages and medieval trash pits are paved over with subway tunnels? The answer lies in patience and a keen eye for subtle clues. Take Rome, where every shovel of dirt seems to cough up history. Beneath the bustling Piazza Navona, soil cores revealed something unexpected: layers of dark, loamy earth packed with ancient olive pits and fig seeds. This wasn't just random debris, it was the remnants of Emperor Domitian's private gardens, a lush oasis buried under centuries of marble and cobblestone. But cities don't just bury beauty, they hide their messy secrets too. In London, archaeologists digging near the Thames uncovered a striking pattern: alternating bands of black, greasy soil and sterile clay. These were the city's medieval landfills, where generations tossed everything from fish bones to broken shoes. The greasy layers, that's decomposed organic waste, slowly turning into a time capsule of medieval diets and fashions. The clay, deliberate dumping of clean material to mask the smell, proving that urban sanitation struggles aren't a modern invention. Even more fascinating are the lost waterways. Beneath Istanbul's streets, soil analysis detected sudden shifts to sandier, water-worn layers, ghosts of long-vanished Byzantine harbors, now landlocked thanks to centuries of silt and relentless construction. The real detective work begins when these layers get scrambled. In Mexico City, built atop the Aztec capital of Tenochtitlan, the soil tells a story of conquest and adaptation. Spanish colonists, determined to erase the old city, tore down temples and used the rubble as landfill. Today, archaeologists find bizarre mixes pre-Columbian pottery shards cemented together with colonial-era lime mortar, or layers of volcanic ash from ancient eruptions suddenly interrupted by European brick dust. It's a geological palimpsest where each layer isn't just a period in time but a clash of cultures. Yet amid the chaos, there are moments of eerie preservation. Beneath modern Copenhagen, a thick, waterlogged layer of peat protected an entire medieval neighborhood: wooden shops, fish racks, even a forgotten bowling alley, sealed in a soggy time capsule. The peat's lack of oxygen prevented decay, leaving behind a snapshot of daily life so vivid, you can almost smell the smoked herring. Similarly, in Boston's Big Dig project, workers slicing through landfill uncovered colonial-era privies, underground outhouses filled with layers of discarded oyster shells, medicine bottles, and even centuries-old peach pits. These weren't just trash pits, they were accidental archives where the very act of urban expansion became an excavation. What makes urban archaeology so thrilling is its constant tension between destruction and discovery. Every new skyscraper's foundation risks slicing through irreplaceable history, but sometimes it's that very disturbance that brings the past to light. In Tokyo, subway construction exposed layers of charred wood and ash, revealing not just one great fire but dozens, each band marking the city's cycle of burning and rebuilding. And in Paris, the catacombs, originally just limestone quarries, became accidental museums when centuries of graveyard soil was hauled underground, carrying with it fragments of every era the city ever lived through. The lesson: cities aren't just built on top of history, they're built from it. Every brick, every road, every park is a collaboration across centuries, with the soil as the silent scribe. And while urban archaeology might feel like trying to solve a puzzle with half the pieces missing, those remaining fragments, a seed, a shell, a streak of ash, still tell a story richer than any textbook. Deciphering the hidden stories in soil isn't just about looking, it's about measuring, comparing, and sometimes even seeing through the earth itself. Archaeologists rely on tools as precise as a painter's palette to decode these colorful histories. Enter the Munsell color chart, a humble yet revolutionary device that turns subjective descriptions like rusty brown or dull gray into universal scientific language. Picture a small book filled with swatches, each assigned alphanumeric codes. By holding soil samples against these pages under consistent light, researchers can record colors with lab-grade accuracy. A layer labeled 10YR5/4 might not sound poetic, but to an expert it screams flood deposit or ancient hearth, depending on the context. This standardization means a team in Turkey and another in Peru can speak the same chromatic language, ensuring discoveries stack up across continents and centuries. But color is just the first clue. To uncover the full story, scientists turn to X-ray fluorescence, a handheld marvel that beams X-rays into soil and reads the elemental symphony bouncing back. In seconds, it can detect traces of lead from Roman plumbing, mercury from medieval alchemy, or even zinc from long-vanished trade goods. At a Viking Age marketplace in Sweden, this technique revealed invisible hotspots of copper and tin, evidence of a bustling metalsmithing district that left no visible ruins. The soil remembered what wood and stone had forgotten. Then there's the game-changer, ground-penetrating radar or GPR. Imagine pushing a lawnmower-like device over a field and watching a screen as it paints a 3D map of buried walls, pits, and even decayed wooden posts, all without lifting a shovel. In Italy's Pompeii, GPR recently exposed an entire block of intact shops and homes still sealed under volcanic ash, their outlines crisp as yesterday. The real magic, these layers aren't just shapes, they're time stamps. A GPR scan of a British pasture might show Roman cobblestones slicing through older Celtic post holes, revealing how one civilization literally paved over another. Yet for all their high-tech prowess, these tools still demand a human touch. A Munsell chart can't explain why certain colors cluster in ritual spaces. X-ray fluorescence might flag elevated phosphorus levels, but only context tells us if it's from a feast or a funeral. And while GPR can spot a buried ditch, it takes an archaeologist's intuition to recognize it as a defensive trench rather than an irrigation channel. The most powerful tool remains curiosity, the willingness to ask not just what and where, but why. After all, soil analysis isn't just about collecting data. It's about reconstructing the moments, decisions, and lives that turned dirt into history. Even the most vivid soil layers can be masterful tricksters, hiding their true origins behind ambiguous colors and textures. Take the infamous black mat of North America, a dark, carbon-rich band dating back nearly 13,000 years, coinciding with the mysterious disappearance of mammoths and the Clovis people. Some researchers point to its global presence and microscopic diamonds as smoking gun evidence of a cataclysmic comet impact, an event so violent it might have triggered an ancient climate shift. But peer closer and the picture blurs. Skeptics argue this layer could simply mark a prolonged wet phase, where swampy conditions preserved organic matter in a perfect storm of natural decay. The debate isn't just academic, it's a high-stakes detective story where soil scientists and astronomers clash over the Earth's cryptic handwriting. These controversies reveal a deeper truth. Nature and human hands often leave eerily similar fingerprints in the dirt. In the Amazon, patches of unusually dark earth were long celebrated as proof of vast prehistoric cities until soil chemists noticed identical formations near termite mounds, where insects had patiently enriched the soil over millennia. Similarly, those striking red layers in Mediterranean sites might signal ancient ironworking, or just the relentless oxidation of perfectly ordinary rocks. The challenge isn't just distinguishing human from natural, it's recognizing where the two conspired. At Britain's Hadrian's Wall, rust-colored soils initially thought to be slag from Roman forges turned out to be natural iron deposits that attracted metalworkers in the first place. The Earth didn't just record history, it shaped it. What keeps archaeologists awake at night are the maybe layers, streaks of color that defy easy categorization. The thin white bands in Chilean desert soils could be salt from evaporated irrigation canals, or mineral deposits from rare rainfall events. The ashy lines beneath Greek temples might represent sacrificial pyres. Or volcanic fallout from distant eruptions. Even microscopic clues can mislead. Tiny magnetic particles might indicate ritual burning or lightning strikes. The only way forward is a toolkit of cross-verification, radiocarbon dating to check timelines, pollen analysis to reconstruct environments, and isotopic studies to trace elements back to their sources. Perhaps no site embodies these interpretive battles like Turkey's Göbekli Tepe. Its circular structures, buried for millennia under carefully arranged layers of gravel and soil, sparked wild theories, from ceremonial centers to cosmic observatories. But when geologists studied the soil compaction, they noticed something mundane yet revolutionary. The ritual layers matched patterns created by rainfall on unstable slopes. Could this monumental site have been partly preserved by accident, its builders fighting a losing battle against erosion rather than encoding celestial secrets? The dirt holds the answer, but it speaks in riddles that change with every new scientific lens we apply. These debates aren't failures of science, they're its lifeblood. Every contested layer forces researchers to ask better questions, invent sharper tools, and embrace humble uncertainty. After all, soil isn't a history book with neat footnotes. It's a palimpsest where nature and culture scribble over each other in disappearing ink. The real discovery isn't always the right interpretation, but the thrilling moment when the ground reminds us how much we still have left to learn. The Little Ice Age wasn't just a dip in temperatures, it was a slow, relentless squeeze on civilizations, and the soil bears the scars. Peat bogs, those waterlogged time capsules, tell one of the clearest stories. As the world cooled from the 14th to 19th centuries, these spongy wetlands began preserving organic matter with almost eerie precision. Normally, plant matter decomposes steadily, leaving behind dark, crumbly layers. But during the coldest decades, something remarkable happened. The bogs started producing lighter, fibrous bands where moss and reeds remained eerily intact. It's as if the earth itself hit pause. Bacteria and fungi, sluggish from the chill, couldn't break down vegetation as quickly. In Ireland's bogs, these pale, straw-colored layers align perfectly with historical records of failed harvests and famine, the unrotted plants standing like ghostly witnesses to years when summer never truly arrived. But the coldest chapters left even more dramatic marks. When glaciers advanced, creeping down mountains like frozen tongues, they scraped bedrock into fine, mineral-rich dust. As temperatures inched upward again, meltwater carried this powder downhill, depositing it in valleys and plains as distinct, pale stripes in the soil. In the Swiss Alps, these silty layers alternate with darker bands of organic material, creating a striped record of advance and retreat. What's chilling is how these geological events sync with human crises. A thick mineral layer in Norway's fjord soils, dated to the mid-17th century, coincides with the abandonment of entire farmsteads. Ice had stolen their growing season, and the ground kept score. Yet the soil's testimony goes beyond simple cause and effect. In the Netherlands, where farmers battled rising seas and sinking land, a unique pattern emerged. Thin, sandy layers interrupted by sudden deposits of peat. These weren't natural, they were acts of defiance. As storms eroded coastal soils, Dutch villagers hauled in peat from bogs to reinforce dikes, mixing the earth's layers in a desperate bid to hold back the water. The soil here isn't just a climate record, it's a ledger of human ingenuity under pressure. Perhaps most haunting are the vineyard soils of France. Burgundy's prized Pinot Noir grapes thrive in limestone-rich earth, but during the Little Ice Age's worst years, a strange grayish band appears, a layer where vine roots stopped growing entirely. Wine archives from those years note harvests so late that grapes barely ripened before frost, yielding thin, acidic wines. The soil and the scribes agree. This was an era when even the most resilient traditions bent to the cold. What makes these layers so vital is how they rewrite the narrative of hardship. Historical accounts often focus on kings and battles, but the soil remembers the quieter struggles. The farmer who switched from wheat to hardier rye, the village that moved downhill as frosts lingered. In the Scottish Highlands, patches of unusually dark soil mark where families burned seaweed to warm frozen fields, a trick born of necessity. In colonial America, settlers' diaries complain of years without summer, while the soil beneath their abandoned cabins holds pollen from invasive weeds that thrived when crops faltered. The lesson isn't just about survival, it's about adaptation. When researchers compared soil layers from different regions, they found a pattern. Communities that diversified crops or shifted grazing patterns left behind more complex, nutrient-rich layers. Those that clung to failing systems saw their soils thin and fade. The earth doesn't just record disaster, it reveals the choices that made the difference between collapse and resilience. And as we face our own era of climate shifts, these colorful layers offer more than history. They're a field guide for weathering the storm. Beneath the sterile crust of abandoned fields and buried courtyards, the earth still cradles the ghostly outlines of gardens lost to time. These weren't just patches of greenery, they were living pharmacies, open-air pantries, and sacred spaces, their secrets locked in soil chemistry and trapped pollen grains. Take the volcanic ruins of Pompeii, where scientists made an astonishing discovery. Pockets of Earth so rich in phosphorus and nitrogen, they glowed like beacons in lab tests. These weren't random nutrient spikes, they were the molecular echoes of rose bushes and lemon trees that once perfumed aristocratic villas. By matching these chemical hotspots with pollen samples, researchers could trace the exact layout of courtyard gardens, down to the parsley borders and trellised grapevines. Even the voids left by decomposed roots became blueprints, revealing where figs and olives once stretched toward the sun. But gardens weren't just about beauty, they were survival. In medieval monastic sites across Europe, soil analysis uncovered something unexpected. Layers peppered with microscopic traces of henbane, foxglove, and other potent herbs. These weren't weeds, they were the ingredients of early medicine cultivated in carefully tended plots. The soil told a story of trial and error. Patches where certain plants thrived and others failed, their success written in the shifting ratios of minerals and organic matter. At England's Revolx Abbey, a sudden spike in lead contamination marked the moment monks began using metal-lined troughs to distill remedies, their experiments leaching into the earth like a parchment of progress. The real revelation came when scientists started reading the dirt like a farming manual. In the terraced fields of Peru's Sacred Valley, alternating layers of fish bones and corn pollen revealed an ancient crop rotation system far ahead of its time. The Inca didn't just plant and harvest, they engineered the soil itself, building fertility with deliberate deposits of anchovy meal and crushed shells. Similarly, in the vanished Viking settlement of Garthar in Greenland, a puzzling lack of barley pollen in later layers told a grim tale. As the climate cooled, settlers clung to failing European crops instead of adopting native plants, their stubbornness preserved in the thinning, nutrient-starved earth. Yet some of the most poignant garden resurrections happen on the smallest scale. In a forgotten corner of Istanbul's Hagia Sophia complex, soil tests detected traces of myrtle and cypress pollen species with no practical use, but deep symbolic meaning in Byzantine rituals. These weren't crops, they were living theology cultivated to mirror the Garden of Eden during imperial ceremonies. And in the American South, the faintest discoloration in slave quarter soils has unveiled hidden spiritual gardens, where enslaved people surreptitiously grew okra and sesame seeds carried from Africa, turning bare dirt into a silent rebellion of roots and remembrance. What's extraordinary is how these gardens defy time. In Japan's tsunami-ravaged Sendai region, researchers found surviving patches of 8th century aristocratic garden soil, its distinct blend of sand and charcoal intact beneath modern rubble, a testament to Heian-era landscaping genius. Meanwhile, in the drought-stricken American Southwest, the ghostly footprints of ancestral Puebloan waffle gardens reappear after rains, their grid-like soil patterns engineered to trap every precious drop. These aren't just archaeological curiosities, they're living lessons in sustainability, waiting for us to read them. The soil's greatest gift might be its refusal to let us forget. When modern bulldozers sliced through London's bomb sites after World War II, they exposed something miraculous: Victorian flower beds, their bone meal fertilizers, and exotic plant pollens perfectly preserved under the rubble. Even in annihilation, the earth remembered beauty. So the next time you walk past a vacant lot or a weedy field, look down. That unassuming dirt might be holding the design for a Roman herb garden, a Ming Dynasty lotus pond, or a pioneer's kitchen plot, all patiently waiting for someone to dig up their stories. Animal footprints pressed into ancient mud aren't just fleeting marks, they're frozen moments, captured in soil like a prehistoric security camera. Take the Litoli footprints in Tanzania, where 3.5 million years ago, a light rain fell over fresh volcanic ash, creating the perfect canvas for early hominins to walk side by side. Their tracks, preserved like nature's own cement, reveal not just how they moved, but how they lived, striding purposefully, perhaps as a family, their heel strikes and toe drags telling a story of posture, gait, and even social bonds. Fast forward to medieval Europe and the story shifts. Pressed into the clay floors of abandoned farmsteads are the deep, crescent-shaped grooves of oxen hooves, their repetitive paths mapping out the back-breaking labor of plowing fields that fed entire villages. But it's not just about who walked where, it's about the invisible ecosystems these tracks unveil. In Australia's Willandra Lakes region, a single set of emu footprints, preserved in hardened clay, tells a haunting tale. The prints start strong and clear, then stagger left and right, as if the bird was injured or exhausted. Nearby, human footprints intersect the trail. Was this a hunt, a rescue? The soil won't say, but the tension of that moment lingers in the dirt. Similarly, in New Mexico's White Sands National Park, a ghostly parade of mammoth tracks crosses paths with human footprints, some tiny, likely a child's, etched into the same ancient shoreline. The prints don't overlap, but their proximity paints a scene. Humans shadowing megafauna, not yet hunting, perhaps just watching in awe. The real detective work begins when tracks cluster. At England's Formby Point, layers of preserved mudflat hold a chaotic menagerie. Red deer sprinting, aurochs lumbering, and crane birds stepping delicately between them. The spacing of hoof prints reveals herd behavior, whether animals moved in tight groups or scattered, offering clues about predation pressure. Even more telling are the human footprints mixed in, some barefoot, others with the telltale ridges of woven shoes, chasing or herding or simply sharing the landscape. In the Arabian desert, a slab of limestone cracked open to reveal a trackway of camel prints so densely packed, they sketch a caravan route used for centuries, the soil remembering journeys that scrolls and stone markers forgot. Yet some of the most poignant prints aren't dramatic at all. In a Viking Age settlement in Iceland, archaeologists found a single, perfect sheep track pressed into the doorstep of a longhouse. This wasn't a wild stampede or a hunt, just a moment of daily life, a hoof print in the mud as someone ushered animals inside for the night. Nearby, the smaller, sharper marks of a dog's paws loop around the house, a loyal companion pacing its territory. These aren't grand historical events, they're intimate glimpses, the kind of ordinary moments that rarely make it into sagas or chronicles. The soil preserves what words often ignore. What's astonishing is how these impressions defy time. In South Africa's Cape South coast, a team recently uncovered tracks of a long-extinct short-faced hyena, its distinctive two-toed prints frozen mid-stride. No bones were found, just this one fleeting press of a paw, evidence that the species lingered longer than fossils suggested. Similarly, in Alaska's permafrost, woolly rhinoceros tracks, preserved for 40,000 years, show the beasts wallowing in muddy hollows, their massive bodies leaving behind bathtub-sized depressions. These aren't just footprints, they're time machines, transporting us to mornings when the mud was fresh, the air humming with insects, and the ground still trembled under the weight of creatures we'll never see alive. The lesson: every footprint is a collaboration, an animal's weight meeting the Earth's memory. And whether it's a child's bare foot skidding in Neolithic mud or the last steps of a mammoth on an Ice Age riverbank, these tracks remind us that history isn't always written in stone. Sometimes it's written in dirt, one step at a time. The Industrial Revolution didn't just change the way we lived, it rewrote the Earth's chemistry, leaving behind soil layers so distinct they might as well be neon signs screaming human impact. Take a core sample from any major city's outskirts, and you'll hit a stripe of grimy, grayish-black soil packed with coal, ash, and cinders, a permanent tattoo from the era when smokestacks ruled the skyline. These layers aren't just dirty, they're time capsules of industry's explosive growth. In London's Thames estuary, for example, sediment cores reveal a sudden, dramatic shift around the early 19th century. A thick band where lead levels spike tenfold, mercury makes its first appearance, and tiny spheres of industrial fly ash outnumber natural minerals. This isn't just pollution, it's the moment humanity's footprint turned into a stomp. But the real shock comes when you compare these industrial marks to natural soil formation. Before factories, soil layers changed gradually, shaped by centuries of gentle decay and mineral weathering. Post-industrial revolution, the Earth's diary starts reading like a thriller. In Pittsburgh's riverbanks, archaeologists found a single 4-inch layer packed with enough arsenic to kill a small mammal, a relic from the city's steel heyday, when waste was dumped straight into the water. Similarly, in Belgium's Meuse Valley, the soil still holds a rust-colored stripe of cadmium and zinc from smelters that poisoned entire fields in the 1800s. These aren't subtle shifts, they're geological screams, moments when the balance between humans and nature tipped violently. Yet these polluted layers aren't just doom and gloom, they're also blueprints for redemption. In Germany's Ruhr Valley, once a wasteland of coal mines and blast furnaces, scientists use these very bands to track cleanup progress. By comparing pre-industrial soil layers to the toxic strata above and the healthier dirt now being laid down, they can measure exactly how much lead has been filtered out by new forests, or how wetland restoration has locked away leaking chemicals. It's a living timeline of destruction and recovery, written in dirt. Even more hopeful are the accidental remedies, like in New York's Central Park, where decades of fallen leaves have buried the worst industrial grime under a foot of fresh, clean compost, creating a natural cap that seals the past away. What's haunting is how these industrial layers mirror societal choices. In Manchester, England, the soil tells a tale of two revolutions. First, the dark bands of early textile mills. Then, a century later, a lighter, sandier layer where the city began paving over its filth with concrete and parks, a literal cover-up. In contrast, Detroit's industrial strata show a different pattern, layers of motor oil and rubber particles peaking in the 1950s, then thinning abruptly as factories shuttered, leaving behind an eerie, half-cleaned canvas. The dirt remembers not just what we did, but when we stopped, paused, or tried to reverse course. Perhaps the most sobering lesson lies in the comparison between East and West. Soil cores from the Erzgebirge Mountains, straddling Germany and the Czech Republic, reveal a Cold War experiment no one intended. The eastern side, under Soviet control, has thicker, more toxic layers from unfiltered coal burning, while the western side's bands show lower sulfur thanks to early pollution controls. The border isn't marked by fences in these cores, it's etched in chemistry. A stark reminder that political decisions seep into the ground just as surely as rain. But here's the twist. Some of the most polluted soils are now becoming historical archives in their own right. In Cornwall, the bright red streaks left by tin and copper mining, once ecological disasters, are now treasured markers for historians, helping locate lost workshops and smelting sites. Similarly, the distinctive cinder soils of old railroad beds have become guides for urban archaeologists, leading them to forgotten depots and roundhouses. Even pollution, it seems, can become precious when viewed through the long lens of time. The takeaway: industrial soil layers are more than scars, they're the Earth's way of holding up a mirror. They show us the speed at which we altered the planet, yes, but also how quickly nature can rebound when given the chance. Those grimy bands of coal, ash, and heavy metals aren't just warnings, they're the first drafts of a recovery manual, written in the only language the ground knows how to speak. And as we dig into them, we're not just uncovering our mistakes, we're finding the tools to fix them. Beneath the waves, where sunlight barely reaches, lies a world of forgotten soil layers of Earth so perfectly preserved, they're like time capsules sealed by the sea itself. Take Doggerland, the vast prehistoric landscape now submerged beneath the North Sea. 8,000 years ago, this was no watery grave but a thriving ecosystem: rolling hills, dense forests, and river valleys teeming with life. When rising seas swallowed it whole, something remarkable happened. The lack of oxygen in these underwater tombs slowed decay to a crawl, locking pollen, seeds, and even animal dung in a state of suspended animation. Now, when fishermen trawl these depths, their nets sometimes haul up more than fish. They pull lumps of peat holding perfectly preserved tree stumps, antler tools, and the bones of aurochs that once roamed this lost world. But Doggerland is just the beginning. Off the coast of Florida, buried under layers of marine sediment, lies the ghostly outline of a Paleo-Indian settlement. Here, the soil tells a story without a single artifact. Dark, organic, rich patches mark where ancient hearths once flickered, their charcoal stains still sharp after millennia. Nearby, compressed layers of shells and fish bones outline communal feasting areas, while strange, zigzagging grooves in the clay betray the locations of long-vanished fishing weirs, wicker traps set by people who understood the rhythms of tides and migrations better than we ever could. Without pottery or tools, the soil alone paints a portrait of daily life, from where they cooked to how they harvested the sea. The real magic happens when these submerged soils are studied in cross-section. In the Black Sea, where anoxic waters create a natural preservation lab, researchers have uncovered farm fields frozen in time, plow furrows still crisp, as if the farmer stepped away yesterday. The soil's chemistry reveals even subtler secrets. Patches rich in nitrogen and phosphorus show where livestock pens once stood, their manure enriching the earth for centuries after. And in one haunting case, a child's footprint was found pressed into a submerged riverbank, the tiny toes perfectly outlined in silt that hardened like concrete before the waters rose. These aren't just archaeological sites, they're moments stolen from time where the sea didn't erase history, it pickled it. What makes these drowned landscapes so invaluable is their neutrality. On land, soil layers are constantly reshuffled by wind, worms, and later settlers. But underwater, the sediments settle into near-perfect chronological order, like pages in a book that no one's thumbed through. In Norway's fjords, melting glaciers have exposed entire shorelines where Mesolithic hunters once camped, their hearths and trash pits lying undisturbed beneath meters of icy mud. The layers are so pristine, scientists can track seasonal movements, lighter summer soils rich with fish bones giving way to darker winter layers packed with reindeer marrow, proving these weren't random nomads but strategic planners who followed nature's calendar. Yet the grandest revelation might be how these submerged soils rewrite human migration. Off Australia's northwest shelf, sonar has revealed a sunken labyrinth of river channels, potential highways for the first Aboriginal peoples 60,000 years ago. Soil cores from these drowned valleys contain microscopic charcoal, hinting at controlled burns to manage vegetation, a practice still used by indigenous communities today. Similarly, in the Persian Gulf, patches of freshwater peat beneath the seabed suggest lush oases that could have supported early humans fleeing Africa, their routes now hidden under 30 meters of salt water. The soil doesn't just preserve the past, it redraws the maps we thought we knew. Perhaps the most poignant lesson lies in the fragility these layers expose. In the Baltic Sea, perfectly preserved fishing nets from 9,000 years ago, woven from willow bark, tell of a society that lived in harmony with rising waters, adapting their tools as shorelines retreated. Their solution wasn't walls or barriers, but innovation and acceptance, a wisdom etched into the very dirt they left behind. As our own coastlines face rising seas, these submerged soils offer more than history. They're a challenge, asking if we'll fight the inevitable or learn like they did to move with the tide. The Amazon rainforest has long been painted as the ultimate untouched wilderness, a vast, impenetrable jungle where small tribes lived in harmony with nature, leaving barely a footprint. But the soil tells a different story. Beneath the towering canopy, scattered like hidden breadcrumbs, lie mysterious islands of black earth so rich and fertile. They defy everything we thought we knew about this landscape. Locals call it Terra, Preta, black earth in Portuguese, and it's not just dirt. It's a fingerprint of lost civilizations, a deliberate creation of people who didn't just survive in the Amazon, they engineered it. What makes these dark patches so extraordinary is their stark contrast to the surrounding soil. Most of the Amazon's ground is notoriously poor, thin, acidic, and drained of nutrients by relentless rain. Yet Terra Preta is packed with charcoal, broken pottery, fish bones, and compost, forming a self-renewing super soil that remains fertile centuries after its creators vanished. Modern farmers still seek it out, planting crops directly in these ancient gardens because nothing else compares. But the real revelation isn't just the soil's quality, it's the scale. Satellite imagery and ground surveys now suggest these patches cover an area the size of France, hinting at a network of settlements far larger and more sophisticated than historians ever imagined. The secrets of Terra Preta lie in its recipe. Indigenous people didn't just enrich the soil, they transformed it by slow burning organic waste in smoldering pits, a process called slash and char. They created biochar, a porous charcoal that acts like a sponge for nutrients and water. Mixed with pottery shards for drainage and compost for fertility, this blend became a perpetual growth machine. Even more astonishing, the soil regenerates itself. Microbes thrive in the biochar's labyrinthine structure, breaking down new organic matter and locking it in place. While modern fertilizers wash away after a few seasons, Terra Preta gets richer over time, a technology so advanced, scientists are still unraveling its secrets. But the implications go beyond agriculture. The sheer density of Terra Preta sites suggests the Amazon was once dotted with bustling towns, connected by roads and waterways. In Bolivia's Llanos de Mojos, researchers have uncovered vast geometric earthworks, ditches, mounds, and canals buried under what was assumed to be pristine forest. These weren't just villages, they were landscapes sculpted for farming, fishing, and ceremony. Pottery fragments and tool shards found in the dark earth tell of artisans, traders, and possibly even stratified societies with specialized labor. Far from a green desert, the pre-Columbian Amazon may have been more like a garden city, home to millions. The most haunting question is what happened to these societies. The leading theory points to European diseases which raced ahead of conquistadors, wiping out up to 90% of the population. Without people to maintain their fields and canals, the jungle reclaimed the land, burying the evidence under centuries of growth. Yet the soil remembers. In the Xingu region, Terra Preta layers align with oral histories of a great dying, where thriving communities vanished in living memory. The earth itself became their archive, preserving not just their tools, but their very relationship with the land. Today, Terra Preta is more than an archaeological curiosity, it's a lifeline. As the world grapples with deforestation and climate change, these ancient patches offer a blueprint for sustainable living. Indigenous groups in the Amazon are reviving the techniques of their ancestors, blending biochar with modern agroforestry to heal degraded soils. Scientists, too, are racing to decode the recipe, hoping to adapt it for global use. The irony is profound. A civilization once written off as primitive may hold the key to saving our future. And it's all written in dirt, the kind that doesn't just feed crops but rewrites history. The future of soil archaeology isn't just about digging deeper, it's about seeing smarter. Imagine a machine that can scan a handful of dirt and instantly decode its hidden stories, spotting patterns too subtle for the human eye. That's exactly what artificial intelligence is bringing to the field. Researchers are now training AI algorithms to recognize microscopic soil structures, mineral compositions, and even the faintest chemical traces left by ancient activities. In a recent experiment in Turkey, an AI system analyzed layers from a Bronze Age site and flagged a nearly invisible band of phosphorus, a clue that led archaeologists to uncover a forgotten garbage pit filled with fish bones and olive pits, rewriting assumptions about the diet of that era. This isn't just faster analysis, it's like giving scientists a time-traveling microscope. But the revolution doesn't stop at the lab. Portable X-ray fluorescence spectrometers, devices no bigger than a hairdryer, are turning fieldwork into real-time detective work. Picture an archaeologist holding one over a patch of soil in Greece, watching the screen light up with spikes of copper and tin. Within seconds, they've identified the exact spot where a Mycenaean metalsmith once worked without ever lifting a trowel. These handheld marvels are revealing trade routes, workshop locations, and even ritual sites by reading the elemental fingerprints humans left behind. In Cornwall, a team using this tech discovered a Roman-era tin processing camp simply by following a trail of lead isotopes in the dirt, invisible to the naked eye but glaringly obvious to the machine. Then there's the silent witness in every soil sample, ancient DNA. Scientists are now extracting genetic material not from bones or artifacts, but from the soil itself. In a Siberian cave, researchers sifted through layers of sediment and found mammoth DNA not from fossils, but from microscopic skin cells and hair follicles that had shed into the ground 30,000 years ago. The same technique is uncovering vanished ecosystems in the Amazon, where soil samples hold genetic echoes of cultivated crops and medicinal plants grown by pre-Columbian societies. Even more astonishing, in a cave in Spain, soil analysis revealed Neanderthal DNA alongside traces of chamomile and yarrow, hinting at herbal knowledge long predating modern humans. What's truly groundbreaking is how these tools are converging. AI can now cross-reference spectral data, DNA fragments, and chemical residues to reconstruct entire landscapes. At a site in Jordan, this combo revealed something extraordinary. Layers of soil rich in wheat pollen and sheep DNA abruptly covered by a sterile band of dust, evidence of a climate catastrophe that may have inspired biblical famine stories. Meanwhile, in Mexico, machine learning passed thousands of soil samples to map the rise and fall of Teotihuacan's urban gardens, showing how its citizens adapted crops to droughts over centuries. Yet for all their power, these technologies have an unexpected humility. They're not replacing archaeologists, they're amplifying their intuition. that faint discoloration a veteran excavator might dismiss as nothing. The spectrometer spots elevated calcium levels suggesting a collapsed lime plaster wall. The patch of earth that looks uniform, AI detects a microfossil pattern indicating an ancient compost heap. It's a partnership, human curiosity asking the questions, machines revealing answers hidden in plain dirt. The implications stretch far beyond archaeology. Farmers are using these same soil DNA techniques to track crop diseases through time, while climate scientists analyze ancient soil layers to predict future rainfall patterns. Even space agencies are paying attention. NASA now studies terrestrial soil archives to refine its search for life on Mars, where layers of sediment might hold similar clues. The ground beneath us, it turns out, isn't just a record of where we've been, it's a map to where we're going. And with every scoop of soil now holding the potential to rewrite history, the future of archaeology isn't just in the earth. It's in the invisible worlds waiting to be decoded. Every shovel of dirt removed from an archaeological site is a page ripped from history's book, one that can never be perfectly put back. This irreversible act sits at the heart of modern archaeology's greatest ethical dilemma. How much should we uncover now, and how much should we leave untouched for future generations who may have tools we can't yet imagine? It's a tension between knowledge and preservation, between satisfying our hunger for the past and safeguarding its integrity. Take the tomb of China's first emperor, Qin Shi Huang. His burial mound, rumored to contain an underground palace with rivers of mercury, remains largely unexcavated, not because we lack curiosity, but because current technology can't guarantee the preservation of its potential paintings, silks, and organic materials. The soil here isn't just a barrier, it's a temporary guardian, buying time for science to catch up to history's secrets, but the choice isn't always so clear-cut. When builders in London stumbled upon the Bedlam burial ground, a 17th-century plague pit during construction of the Crossrail project, archaeologists faced a brutal calculus. Digging meant disturbing thousands of skeletons, but delaying risked exposing the remains to modern contamination. The compromise, a meticulous rescue excavation, where every bone and artifact was documented in 3D before reburial elsewhere. This hybrid approach acknowledges a painful truth. Sometimes the act of preservation requires temporary destruction, yet even this middle ground sparks debate. For every artifact saved, how much contextual information, the precise angle of a skeleton's burial, the pollen trapped in adjacent soil, is lost forever when layers are disturbed. Enter the rise of non-invasive archaeology, a suite of technologies promising knowledge without excavation. Ground-penetrating radar maps buried structures like a medical MRI scans tissue. LiDAR lasers reveal lost cities beneath jungle canopies without cutting a single vine. At Stonehenge, soil resistivity surveys recently uncovered a ring of prehistoric shafts 2 miles wide, a monument hidden for millennia, now revealed without a single trowel breaking ground. These methods feel like ethical triumphs, but they come with limitations. Radar can't tell us the chemical composition of a cooking pot. LiDAR won't reveal the DNA in a skeleton's teeth. For some questions, dirt must still be moved, layers irreversibly crossed. The most heated debates erupt over sites tied to living cultures. In Australia, the ancestors of the Ngarrindjeri people still share oral histories about their burial grounds near Lake Alexandrina. When erosion exposed ancient remains, elders faced an impossible choice: excavate to protect them from looters, or leave them to natural decay as tradition dictated. The solution emerged from dialogue, a blend of drone monitoring to track erosion and selective reburial of the most vulnerable remains. It's a reminder that soil isn't just an archive. For many, it's sacred ground with rights of its own. Perhaps the boldest experiment in restraint is happening in Norway's melting glaciers, as climate change reveals Viking artifacts frozen for 1,000 years. Archaeologists aren't rushing to collect everything. Instead, they're prioritizing organic materials like leather and wood items that decay fastest once exposed, while leaving metal tools embedded in ice, betting that future technologies might extract their stories with less damage. It's a gamble, trusting time and temperature, but also an act of humility. The soil, the ice, the layers we're so eager to decode, they've kept these secrets safe longer than our civilization has existed. The real question isn't just what we can uncover today, but what legacy of curiosity and respect we'll leave for those who dig through our own layers someday. Your backyard might seem like just another patch of grass, but it could be hiding layers of history waiting to be read, like a mystery novel written in dirt. Start by grabbing a garden trowel and digging a small test pit about a foot deep. As you scrape away, pay attention to the subtle shifts underfoot, a sudden change from dark, crumbly soil to compacted yellow clay. That could mark where an old path or foundation once pressed into the earth. If you hit a streak of ashy gray, you might be standing over the remnants of a long-forgotten burn pile or hearth. Even unassuming pebbles can tell tales. A cluster of oyster shells in landlocked Kansas might trace back to a pioneer's discarded supper or a railroad worker's lunch. For a deeper dive, try the jar test. Fill a clear container with soil from different layers, add water, shake vigorously, and let it settle. The particles will separate into bands, sand sinking fastest, silt in the middle, clay on top. But watch for surprises. Flecks of charcoal could hint at past fires, while rust-colored streaks might signal iron tools left to corrode. In one suburban yard, this simple method exposed a layer of handmade brick fragments, leading the homeowner to discover their property was once part of an early 19th century brickyard. Local archives can turn your dirt detective work into a full-blown investigation. Many county extension offices offer free soil analysis, identifying unusual pH levels or nutrients that don't match the surrounding area, clues to vanished livestock pens or compost heaps. Historical societies often have old plat maps revealing forgotten boundaries. That odd rectangle of sandy soil near your fence line, it could align perfectly with a Depression-era chicken coop sketched on a 1930s survey. The real magic happens when you cross-reference your finds. A depression in the ground filled with darker, richer earth might look like a natural sinkhole until you spot matching depressions at regular intervals. Suddenly, you're not seeing holes, you're seeing post holes from a barn that stood a century ago. One gardener in Vermont noticed her tomatoes thrived in one bed but withered in another. Soil tests revealed the fertile patch was laced with crushed limestone, the ghostly footprint of a pioneer's root cellar that had slowly enriched the earth. You don't need fancy tools to start this conversation with the past. A kitchen strainer can sift out tiny artifacts like buttons or nails. A magnet dragged through loosened soil might snag forgotten hardware. Even the weeds growing in your yard can be informants. Patches of chicory or yarrow, plants often brought by European settlers, might outline an old homestead's herb garden. The key is to observe without rushing. History rarely shouts. It whispers through cracked clay, rust stains, and the stubborn persistence of seeds dropped by hands you'll never meet but can still somehow know. Soil isn't just dirt. It's the world's oldest storyteller, whispering secrets through every subtle shift in texture and hue. Think of the last time you knelt in a garden, crumbling dark earth between your fingers. That richness didn't appear overnight. It's the accumulated memory of centuries, decomposed leaves from generations of trees, bone fragments from long-forgotten meals, charcoal from fires that warmed hands will never touch. These layers aren't passive, they're in constant conversation with us. When archaeologists uncover a Roman vineyard soil, they don't just find grape seeds, they read the desperation in suddenly thicker charcoal layers from a year when frost threatened the harvest, or the prosperity in seashell fragments ground into fertilizer after a bumper trade season. Consider the humble shovel's power as a time machine. In one stroke, it can slice through epochs, the dusty yellow of a medieval plague pit, the ashen gray of a Viking longhouse fire, the vibrant red ochre staining a Neolithic burial. Each color is a vocabulary word in Earth's language. That rusty hue, iron oxides whispering of ancient metalworkers, the Inkai black streak, centuries of decomposed thatch from a Saxon village. Even the scent of freshly turned soil carries history, the tang of acidity from forgotten citrus groves, the earthy musk of rotted oak barrels from Prohibition-era moonshiners. What's extraordinary is how these stories transcend geography. The same reddish-brown iron-rich soils that outline African iron smelting sites appear in the forge pits of colonial Massachusetts. Waterlogged black, anaerobic layers that preserve Neolithic wooden tools in Irish bogs also cradle samurai swords in Japan's rice paddies. This universal language means a farmer in Peru and an archaeologist in Turkey might kneel in identical dirt, reading different chapters of the same human saga, one tracing potato cultivation terraces, the other decoding Hittite temple foundations. Yet the most poignant tales aren't always grand. Sometimes it's the small disturbances, a child's footprint fossilized in mud, the circular stain of a dropped cooking pot, that bridge millennia. In Dorset, England, a peculiar soil pattern led researchers to a Bronze Age toddler's grave. The little one wasn't buried with gold or weapons, but with a handful of wildflower seeds still visible in the earth. 3,000 years later, those tiny imprints speak louder than any treasure hoard about what it meant to love and lose across time. This is why every construction site, every plowed field, every backyard garden is potentially hallowed ground. When workers digging a Berlin subway hit a strange, spongy layer in 2012, they uncovered a World War II bomb shelter's collapsed roof, and beneath it letters, toy soldiers, and a single intact Christmas ornament, preserved in the oxygen-starved mud like insects in amber. Similarly, a Missouri family planting tulips unearthed Civil War-era buttons mixed with pig bones, revealing their home stood on a Union Army camp's butchering station. History doesn't just live in textbooks, it's waiting beneath our swing sets and parking lots, encoded in sediments. The challenge and the thrill is learning to listen. Soil science now employs tools that would stagger our ancestors. Mass spectrometers detecting trace lead from Roman pipes, DNA analysis identifying millennia-old manure, even AI algorithms predicting settlement patterns based on phosphorus distribution. Yet some truths still demand old-fashioned digging. When heavy rains exposed strange soil bands near a Newfoundland fishing village in 2018, an alert local noticed alternating layers of fish bones and hearth ash. That observation led to the rediscovery of a 10th century Viking way station, proving Norse presence in North America centuries before Columbus, all because someone recognized that dirt had a story to tell. So the next time you pass a construction site or hike a trail, watch the exposed earth. Notice where the color deepens, where textures change. That ribbon of white might be crushed limestone from a pioneer's cabin foundation. Those pebbles could be the last remnants of a cobblestone Roman road. Even modern activities leave their mark. Future archaeologists will read our era in microplastic layers and sudden spikes in radioactive isotopes. We're all contributors to this endless archive, adding our lines to the grand narrative written not on paper, but in the very ground we walk upon. The past isn't behind us, it's beneath us, patiently waiting for curious minds to start digging.